All right, we're going to do one last projectile motion problem, and this time I'm just going to be looking for velocity final, okay, in the y direction. We haven't done a lot of these, so that's why I want to do one problem devoted to it. When you're looking for final velocity, I already said why. The reason you're not looking for velocity final in the x direction is because it's already given to you. Remember that acceleration in the x direction is 0, so whatever initial velocity that you're given in the x direction, that's going to be your final velocity in the x direction. So that's not interesting. We only care about the y direction. Okay? Let's write down what we know. We know that that final velocity in the x direction, that final velocity in the final velocity in the x direction is equal to the initial velocity in the x direction, which is equal to 2.5 meters per second. We already know acceleration in the x direction is 0. We know acceleration in the y direction is about -10 meters per second squared, which is gravity, okay? Because remember, we draw an FBD. Oh, look, the only force is down with gravity, and that means that our acceleration must be gravity, right? We are given delta y, which is going to be 4 meters. We don't know delta x. We don't know time. But we don't need that. The only thing we need to figure out is that final velocity in the y direction. And you only need to know how far it's traveling and what its acceleration is in order to figure that out. I'm going to use the formula velocity final squared equal to velocity initial squared plus 2 acceleration in the y delta y. You may have seen this on your formula sheet as plus 2a delta x, but because this is in the y direction, that's why I want to specify y direction with all of them. Okay? Cool. Let's go ahead and plug in some numbers. So we know that velocity final in the y direction squared is going to be equal to our initial velocity, which is 0. Okay? All of this initial velocity is in the x direction. So if we were going to draw a motion map in the vertical direction, it would have to start with a dot and then grow. Okay? Starts at 0, right? Plus 2, acceleration is -10. So I'm including the negative times delta y, which is going to be 4 meters. Okay? Get out our calculator. All we're going to have to do is 2 times -10 times 4. We're going to get velocity final squared in the y direction is equal to -80. Now you know that you cannot put a negative underneath the square root sign, so we're just going to put it to the outside. Okay? So we need the square root of 80, which is going to be velocity final equal to 8.94 meters per second. Okay, the negative matters because it shows direction. He's falling down. So we need to indicate that our direction. We end up with -9.84 meters per second. Right? You could go the roundabout way and solve for delta x and go from there, but this is the easiest way. Right? Use this method.